everybody, this is Morgan here with Positive Approach to Math. Moving on in our functions topic to lesson 2, relations. And with relations, we're going to discuss ordered pairs, tables, graphing, and mapping diagrams. Just a reminder that I will always leave you with problems to try on your own. You can click below in the details to find an answer key of that, where you'll also find a blank PDF of these notes in case you want to fill them out on your tablet or print them out to have. I also have a video linking those U-tries if you need some extra practice or some extra guidance through some more problems relevant to this lesson. Let's get started talking about relations. This is going to set the tone for this entire topic here. So what is a relation? The most basic way I think of a relation is it's literally what it says, a relation between two things. I like to think of it as a mapping of an input, something that you're inputting. Often we talk about X being our input to our output, Y, and it's some way that they're connected. So that's what I'm going to write here, that a relation, it's a mapping of an input to an output. So as you see there, every relation consists of inputs and output values. We put something into our machine and it spits a number out to us, okay? So the first way, and I just started with this, and from here we'll go to all of the other formats, we have ordered pairs. Okay, so ordered pairs we talked about in lesson 1. They're anything that pop up and we know that the X value is always first and the Y value is always second. So a set of ordered pairs, a list of ordered pairs, often describes a relation. And so you can just put them, separate them as you see with a comma. Sometimes you'll see them even like in their own set. So they'll have like these big brackets around them to indicate, okay, that is our relation, those sets of ordered pairs, or that set of ordered pairs. So in this set of ordered pairs, we have 1, 2, 3, 4, 5 points that are defining our relation here. And all of them are in the same format of X comma Y. We know ordered pairs, we've seen them, been there, done that, right? For our table, it's basically, let's say, put all of our X values that we have, and then we're going to put all of the Y values. Now, I'm going to be a little bit particular. Your teacher might differ or might give you a different set of instructions, but I'm going to classify or organize my table by putting the X's in order from least to greatest, just to kind of have like a clear and concise systematic approach to it. So if I look at my ordered pairs, I'm looking for the X that's the smallest, and right off the bat I see -2, but I see it twice. So I'm going to put -2 for the first 2 values, and now to know what I need to put next for its Y, I'm going to, it once again is preference, but I then will say, okay, since there's 2 -2s, which Y is smaller, the 7 or the -5? And in this case, the -5 is smaller, so I'm going to use that ordered pair first. And I like to either like put a little check mark next to that ordered pair so I know I utilized it, or X or cross out, something of that nature. And then the next one, I will just put 7, check, okay? Now the next smallest X value I see is 0, and it's the only one with 0, and its Y value that goes with that 0 is also 0. So I write 0, 0, okay? The next smallest X value I see is an X value of 1. Its Y value is -3. So I put 1, -3. And then the largest X value I have is 3, and its Y value is 4. Okay? So to wrap up a table, we put them in order. My preference is to put them in order based off of their x values from smallest to largest. If you have two of the same x values, you then move to the y and say, okay, which y is smaller? But notice here, after that, it's not necessarily going to fall into place for your y's being in order from least to greatest because you're going strictly off of the x. And you want to make sure, what's important is to make sure that each x is buddying up with its y from the ordered pair. So -2 is buddying up with its -5, its partner in crime. Then -2 is buddying up with 7, its partner in crime. Then 0 is buddying up with 0, so on and so forth. Okay? So that is how we would translate from ordered pairs to tables. I like to think of ordered pairs as like our common language for all. You can easily get from an ordered pair to a table, an ordered pair to a graph, an ordered pair to a mapping diagram. So whenever I see something that's not ordered pairs, it's sometimes easiest to just write them as ordered pairs first before you go ahead and transition to whatever is being asked. Okay, for our graph, this is why I recapped graphing with you in lesson 1, because another way to represent a relation is to just plot the points, plot the ordered pair. So you might see a relation given as a set of points plotted. And so remember how we graph, our first value is x, that tells us where to travel right or left. Our next value is y, that tells us where to travel up or down. So the first ordered pair is 3, 4. So remember, we're always starting at that origin, 0, 0. From there, I'm going to travel right 3, up 4, and put a dot. I do not have to give it an A, B, C because I'm just plotting those ordered pairs that are stated there, okay? The next ordered pair is -2, which tells me from that origin I'm going to travel left 2 and then +7. And I'm going to put a dot. And then next I have 0, 0, which is the origin. So I have a point right there. Next I'm traveling right 1, down 3. So I'm going to go right 1, down 3 from that origin. And then last but not least, I have left 2. X is -2, so I'm going to travel left 2. And then the y is -5, so I'm going to go down 5 and put a dot. Okay, so that's what a relation would look like if I had to graph it. What I will say about this is that if that was given to me first, I would always, 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 always write it as a set of ordered pairs, okay? And then last but not least, we have our mapping diagram. Our mapping diagram does exactly what it says it's going to do. It maps an X to a Y. And so I'm going to label this X and Y. But here's the thing about mapping diagrams. You have to put both the X in order from least to greatest. You want to put the Y's in order from least to greatest. And you want to list no repeats. So, for example, this -2 that we see twice, I'm not going to list it twice, okay? I'm only going to list it one time, and I'll show you how that works. So, -2, and here's the good thing about when you have the table. Your X's are already in order from least to greatest, so that's where that helps you. So I see I have -2 twice, but I'm only going to list it one time. I have 0, 1, and 3. So I make sure my X's are in order from least to greatest. If I see a number twice in my X, I do not list it twice. Cool. For my Y's, same thing. I'm now not matching buddy by buddy. I'm saying let me put my y's in order from least to greatest. So my smallest y is -5. I then have -3, and this is where you might need to like cross off, so you know you used them. I have 0, 4, and 7. Okay? It's okay that I have one more value in the y than I do in the x. That's because none of the y values repeated. Something else I want to be clear is, yes, you see a 0 in the x and you see a 0 in the y. Those are separate categories, so yes, we have to put those zeros twice. We're only not repeating if we see an x value twice in that category, and then we see a y value twice in that category. Okay, now here's the fun part. This is where you get to draw the map. So what we're going to do is we're going to say, okay, what does -2 map to? What's the y value that goes with -2? And we see that it is 7 and -5. So we're going to draw an arrow from -2 to -5, and then we're going to draw another arrow from 2 to 7. Okay, so it has 2 arrows coming out of it, which makes sense because we had 2 ordered pairs with that x value. 0 maps to 0. Okay. 1 maps to -3. And last but not least, 3 maps to 4. And so you can kind of do a self-check here. Does every x have a line coming out of it, 1 or more? And the answer is yes. And does every y receive a line, have an arrow touching it? And the answer is yes. For right now, it's okay if there is more than one line coming out of an x, and if a y is getting a value more than once. Or I should say getting more than one value. Awesome. So that's our mapping diagram. And so, like I said, you'll be able to transfer from any 4 of those versions to any of the others. But the most helpful thing is to put them as ordered pairs. That's a helpful hint that I don't think I stated there, but I find it truly, truly helpful. So, our helpful hints say make sure we always place our x values in order from least to greatest for both the table and the mapping diagram. And for your mapping diagram, we always want to place the y values in order from least to greatest. Something else for our mapping diagram? No repeats. And something else is no matter which version of a relation you're given, it's often always easiest to write the ordered pairs first and then transfer to your other languages, whether it be a mapping diagram, a table, or a graph. So, for example, I give you this U-try. I gave you a relation as a graph. So what I would do is I would first write all of their ordered pairs. Utilize lesson 1, identify the ordered pairs. From there, I would say, okay, let me make my table, let me make my mapping diagram. It's a little bit trickier to go right from a graph to a mapping diagram or a graph to a table. I find it best to get it in an ordered pair because we understand how ordered pairs work, okay? So I do leave you with this U-try. I encourage you to give it a try on your own. I think you can do it. But if you get stuck, please know in that details below there is a video and an answer key so you can check your work or get extra guidance. Keep up the great work. Do all those things of liking, subscribing, and commenting so I can keep making some awesome math videos for you as you move through your math journey in high school. Keep up the great work.